welcome to the second part of the video on how Kubernetes work and how does cloud deployment work. So in the previous video, we saw that we are now in a situation where we have infrastructure as code, meaning that we are in a declarative environment where we specify what resources we need and how those interact together. So how does that all work? How does Kubernetes then know how to put our application up and running? So basically it works by API objects that are defined in Kubernetes. And these can be, for example, like pods, where your application runs inside a container. They can be namespaces, which define an application space that a set of resources belongs to. They can have events, so for example, waves to do integration testing, and these are things that happen before a sync. So let's say before you deploy something, set up a database, and then deploy the application so that the database is already there. You can have config maps, which are very important to override default settings in an application, let's say for a specific environment or for specific users. So once we have these API objects, how does it work? Kubernetes has a control plane, and inside this plane, which is a machine, it runs a API server, which is an API endpoint, let's say, that can be queried and pushed to create these objects. How do we actually create these objects? We do it in a declarative approach. So Kubernetes objects are declarative. You specify information in a YAML file, like how much memory a container needs, or for example, which applications are running on which node. It describes an intent. So Kubernetes is a declarative language to express an intent in a way that's done through, for example, YAML file or JSON files. It also specifies the resources of an application, what policies and restart updates. So if I get an out of memory exception, should I restart right away or should I leave it off? For example, it has a status information to kind of know how that application status needs to be. And it can maintain that with a readiness probe or a liveness probe, polling, like a health check, is the application on. And all of these are defined in a spec, which basically describes the containers. Plus the Docker file, which is used to then build the application. So in order to create your container, run your application, you need a set of specs, so that amount of memory, for example, and a Docker file to then make sure that application can be correctly installed. So once you have these parts together, you use the kubectl apply, and kubectl is an interface that's given to you to the Kubernetes cluster, and via its apply method, you can specify what container to run with which application through a customization file, which includes reference to the deployment file, which has this information, and a service file, for example, exposing a port that's needed by other pods in the same application. Once you have this set of files together, you have now your object defined, and what you do there is you do kubectl apply on a node, so you have a structure which is pyramidal in its growth. So the control plane then runs all the processes, the scheduler, for example. So once we do kubectl apply, we do this on a node, and Kubernetes has a pyramidal structure. So you have a node, inside the node there is a pod, inside the pod there is a container, and inside the container there is your application. So once you have kubectl apply, what happens is that jobs are created to deploy this application. Then the kubectl scheduler living in the control plane assigns the jobs to the pods and then to nodes, which then are deployed within your kubectl or Kubernetes cluster. And the pod goes up, then the container goes up, and finally your application is run with the command specified in the Docker file, or if it can also be specified in your deployment file, and then your application is running. So basically, then your user can access through an ingress. Ingress are another type of Kubernetes object that allows the application to connect. How does the network work? So you basically have a container which includes the DNS server of Kubernetes, which then allows the pods to talk together with the nodes where there is a proxy on, so that the network can interact with the pod. And that way, the ingress controller knows then how to route through the kube proxy to a specific application via the container's DNS server the request from the user. What also the node has, it can be a controller. So for example, you can say, okay, delete this pod, and you would delete the pod, which would then, if you have a restart policy applied to it, it would come back up by itself. A node in Kubernetes can be virtual or physical. And if you want to kind of put that node off, you say that you're cordoning the node, and that means that you make the node unschedulable. So the kube scheduler will never use that node to run a job on, which can be a deploy job. In this process then, just to reiterate, we have API objects which are submitted to a Kubernetes control plane. The API objects are defined in a declarative approach, and they contain a set of information to run the application, and they're defined in a customization file, which includes a deployment file and a service file to define the applications. Then when you apply the configuration to the control plane, the scheduler runs a job that says, okay, we need this kind of pods with these resources to run this application. Then you have the kube API that allows, through the kube scheduler, to assign the pods to a node running, so that the pod is assigned to the node, and then the container is created within the pod, started up, and within the container the application is run. And this is how apps are deployed in 2022. Thank you.